On-site placement and assembly is a critical part of the off-site construction process, in which the manufactured components interface with the building site. During this phase, modules and elements, after being manufactured in the factory and transported, are placed on site and assembled into their final locations. On-site placement and assembly offers a range of benefits in the construction industry. However, this also brings challenges which the industry must address. With most manufacturing carried out in the factory, the duration of the work on site is reduced compared to traditional construction, where all manufacturing assembly is done on site. Depending on the level of completion of components, time on site may vary. Open panels, for example, will require insulation, sheeting and follow-on finishes to be completed on site, whereas volumetric systems can almost plug and play with a minimum work on site. On-site placement and assembly off-site components provide increased predictability of off-site activities, with a reduced labour force compared to constructing the whole building on-site. BIM and IT tools allow for construction sequencing to be simulated prior to on-site assembly. One of the main benefits of on-site placement and assembly is a safer and cleaner working environment compared to stick building everything on site. This can include access via internal staircases instead of scaffolds, reduced time working at height and in hot environments. There is also significant time and cost savings, such as reduced wastage, reduction in temporary works, reduction in labour costs, reduced plant costs, to name a few. Another key benefit can be the reduced construction time, especially in the case of precast components. This removes the need for concrete curing times on site, and in this way can streamline the construction programme. As a result of less time, site processes, plant and personnel on site, water and energy consumption may also be reduced. Demobilisation and clean-up of the site can also be reduced as there is less to be removed from site upon completion. Risks related to site activities are reduced. Quicker on-site operations limit the disruption to the surrounding area. On-site construction requires precise, accurate placement of components, modules and buildings prior to their full assembly. Challenges can arise if even one small component is placed incorrectly. Tolerances in high-rise volumetric construction are a good example of this, as a small vertical deviation in the ground level will result in a larger displacement at the top of the building. Assembly operations need to be planned and accounted at the design stage, with efficient communication between stakeholders throughout the full design and construction process. Skilled workers must have a working knowledge of other trades and specialism. On-site works are typically undertaken by a small team working collaboratively. This requires flexibility within job roles and a dedicated trades to undertake a variety of tasks, normally out with their remit. This requires significant investment in training. However, with the right skills and knowledge, many problems will be avoided. Collaboration and communication must be frequent and efficient. Placement and assembly roles require technical understanding of products and material, and also a knowledge of off-site construction is required. Assembly of modules includes lifting and handling operations, which need to be planned step by step to prevent risks and provide mitigation measures. Manufacturers shall be required to provide information to ensure safe lifting and handling of modules. Safe areas, barriers and personal protective equipment have to be provided, and crane method statements need to be followed strictly. On-site works are typically undertaken by a team of dedicated operatives working collaboratively. Operatives must be able to interpret, manage and adhere to the production schedules to ensure programme remains on track. They must be able to identify and implement corrective and preventative actions to avoid delays. The application of IT tools such as augmented reality and virtual reality can facilitate site installation of services and systems. For example, live inspection, which allows non-destructive testing to construction details and services. Augmented reality can also be used to identify discrepancies between the BIM model and the on-site project. Management of site activities can be supported by the use of innovative software packages. This monitors site operations and can instantly identify and log variations. The use of drones can be applied to carry out checks and inspection at a distance, without interfering with operations and improving health and safety. On-site assembly is part of the off-site project lifecycle when off-site components interface with the building site. On-site placement and assembly can reduce on-site programmes of work in comparison to traditional construction. It also improves health and safety management on-site, dependent on the material and the system manufactured. A challenge, however, can be the stricter tolerances for assembly of off-site components compared to in-situ construction. Reduction in time for off-site improves the environmental impact of off-site construction and reduces hazards and risks. Assembly process can be simulated and, with the advancement of technologies, managing, monitoring and inspection activities can be carried out more easily. Congratulations, you are now off-site ready with knowledge for change in on-site placement and assembly.